G'day guys, it's Calvin from the Cartoon Company in New Zealand. So I've done a little bit of a relocation. Still got the workshop at the big farm, but I've got another little farm just across the road. And I'm sitting here and I'm yet to decorate my lounge with furniture, so it's made the perfect place to build a wiring loom for the job that I'm presently doing. Looking at my view, oh, you can't really see it, but there's little dots over there. They're my sheep. Yep. And there's the digger. We've been pulling stumps out, trying to sort out the place and get rid of a bit of crap. It's interesting enough talking about the digger, because this wiring loom that I'm doing for a link ECU is for a piece of machinery. We're not running the engine. There is no engine controls on the setup, and it happens to be for my mate in Australia, Jesse, who is another farmer, and we kind of do the same sort of stuff. You know, we ride motorbikes, we talk farming. He talks about his big acreage and I talk about my small acreage. We compare sheep. They do a lot of cropping, and in this particular case, I should mention, we modify vehicles. So he happens to have a 1UZ, and he's modifying the piece of equipment he's working on at the moment. Both being that we're farmers, we kind of talk the same language, so we can understand the same sort of scribbles and hieroglyphics. As you'll see here, we've got some measurements. 10 meters on this branch. Oh, to there. 1.8, 500. And it says here it's for a 977 harvester seed destructor monitoring system. Yep, I am wiring a combine harvester with a link ECU. Jesse gave me a few briefs. He said he wanted a display. He wanted to measure the drive shaft RPMs and give it a warning system if it drops below a certain speed. He had 2 temp sensors. I'm not sure if it's diffs or gearboxes, what he's monitoring there. Transfer case units or bearing assembly. It might be bearing hubs. But he's measuring 2 lots of temperatures, and he wanted warnings for those. And we started off discussing an atom, and then he said he wanted some way of detecting if metal went through it, so a knock detection system of some sort.
Alright mate, so this is the actual mill itself. So this piece here is the rotor. This is the bit that spins at 3000 revs. And this bit here is the stator, which sits still, and this is what the knock sensor will be attaching to. Hopefully to one of these M10 bolts here. So as you can see, there's not much clearance once that slips inside. It's pretty tight.
So we went for a monsoon. So for the construction of it, you can see when I was making it, I taped up my lounge floor because it was the easiest way to hold it in place and mark it all out. It's Tefsel wire and Raychem RNF 100 to cover it for the most part, and then this 12 core cabling for the long length in between.
Alright, so now on the machine, and there's the engine sitting right up in there. You sort of see it. Anyway, so this is the main power takeoff from the engine. So we come through this triple, don't worry, that we're getting a new belt for there. Triple ribbed C-section belt, 1-to-1 down to this jack shaft. This is the jack shaft where we're going to have temp 1 and speed 1 into this bearing housing here, and this is the little teeth we were talking about. From there we drive our stalk chopper, which is this one here, which is all those hungry looking blades in there, and then off the inside one we're going to come down and drive the seed destructor, which is what we've been building.
We've got this branch that goes up. We've got our temp sensors. For our speed sensors, I've chosen transmission speed sensors from a 1UZ gearbox or transmission, A340. Common, cheap, lovely choice. And just in case this is a retrofit, we're not sure it's all going to be 100%. There's actually 3 wires in there. If we wanted to put a like a Hall effect in, we can do that as well on that sublead. There's a big firewall plug, and then there is the 10 meters through here right to another firewall plug. And we come along. OBD2 can be plugged in, however there's a few problems there. I'm not going to discuss too much about that, but there's a communication speed. There's a communication speed issue because when we were looking at gauges, I discussed individual gauges for tachos and for the speeds effectively. The first drive shaft speed is going to be engine speed from the actual engine. Because it's a 1-to-1 straight through there, and then it goes back to a coupling, and there's the second drive shaft speed. I believe there's like a slipper clutch unit in it, and if that starts failing, we want to pick up the rest of the unit if it blocks up or something like that happens. But we wanted a little display. I was talking about displays, and I think Link heard me. I was going to go with another branded unit, but Link just recently released this little unit. This is so cool. So cool. So that is a rebranded Gauge Art gauge with the Link logo on it. Keeps it all kind of the same. It's really nice. And I've coupled it with a warning buzzer. That's pretty annoying actually, that buzzer.
Right, now we're up in the engine bay. How's that for a radiator? So this is where engine management is, and the Link will mount somewhere in this general area. And now we have our engine here, big 9-litre turbo inline 6, about 450 horsepower. And there's our power takeoff there, which is then dropping down to our jack shaft down the bottom down there.
So how's it all work? Let's do a really quick test, and I'll show you it in operation. Of course, I'm not testing it on the machine because the machine is in Australia. Whilst I've been doing this job, and I've done a couple of late nights and setting up alarms, we've also had an animal health day on the farm. So I got my lambs in, try to keep them healthy as we can because I want them to grow nice and big for Christmas. Jesse's wiring loom, 4-legged front loader on my lawn.
So the seed destructor itself, the frame attaches to the back of the chassis there. That's 100 by 100 by 10 RHS. Travels under the back axle, attaches to the chassis up there. None of this is done yet, we've got lots more gussets to put on here. Through to where our mill attaches to, and the drive for the mill. So our drive comes down through these bearings to this tyre coupler. This is where speed sensor 2 will be in here. So if that fails, the pulley will still be spinning, the shaft will still be spinning, but the gearbox and that shaft will stop.
Also had some bad news with one of the little ram lambs that I kept. He happened to have extra titties, and that's a bad thing for him, especially because instead of a life of shagging, he's getting a Christmas date with my oven. But he's going to be tasty. And with anything, with the farming, with these sort of jobs, we come across challenges within it, and this one's had its fair share of challenges, but we've got to the end, and probably the only real issue here I had was the gauge, because I'm putting it in as the speed, so that the RPM of the drive shaft is transferred as a speed. So instead of being in the realms of the hundreds, it's in the thousands. So and you can change the reading, you can change the writing on it, which is all cool, but it doesn't allow me to have a warning limit of 1900, which would be, its thinking is 1900 kilometers per hour, but I'm using it as 1900 RPM. And the OBD2, I wasn't too bothered, that wasn't that important to me. Anyway, testing.
So this is all the bit I've made. So we've got our 90-degree drive gearbox. There's a big flange up under there. We've also got an auxiliary oil pump. This is for the oil cooler, and also to feed that top bearing up in there. There's the tyre coupler again. And there's the mill mounted up on the frame. There's the flange and the taper lock that the rotor attaches to. And then here's the back of the header.
In this vehicle, the John Deere, there happens to be a 12-volt fused power supply. So Jesse's going to connect these into the vehicle. I haven't terminated them because he will have the correct plugs, I hope, or do something there. I'm going to power it up. Oh, I know what I was going to do. I was also going to check some amperage draw. 0.24 of an amp. Here's the little screen. It does come out fuzzy because of the camera, unfortunately. It's saying we've got an RPM limit. This here is a 4AGE distributor, and I've got both the speed sensors going to the same reluctor signal. We've got our Bosch temp sensors, nice and easy, commonly available. Can be a VN Commodore. You can go get one of those. Perfect.
So now we're in the back of the header. You've got the chopper there for chopping the straw into little pieces and spreading it back out in the paddock. You've got this big baffle plate here. Everything above the baffle plate is straw without any grain in it from that discharge beater up there. It comes down the baffle plate, and then of course this chopper swings down to join up with the baffle plate. Everything below the baffle plate is grain. There's the sieves. You got the rotor up the front, and the grain that separates the grain from the straw. The grain comes down, goes across the sieves, sieving out all the crap from the bit you want. Anyway, then all the weed seeds and all the small grain and crap ends up coming over the top and down into the destructor, where it then gets shot out the two vanes once I finish them.
And we have a knock sensor, a common Bosch wideband sensor. Simple. I spin this. And I've set up a series of warning systems in the ECU to fire the buzzer, and the gauge itself has got some warning systems as well. Of course, that one doesn't do the second drive shaft speed. It does the main one, but not the second one. Jesse can flip them around if he wants to, so we can change it and configure it. Though I do have to teach the Australian how to use the Link software. I think he can handle it.
Right, now metal management. If anything breaks up the front, and we have nuts or bolts or bits of chopped up wire or retractable fingers or what have you, they have to come down here, and they're going to eventually end up in there. Now the idea is we've got the knock sensor there to let us know if it does make it to here, but the idea is to try and stop it from getting there. So I've made up this magnet tray that sits at the back of the sieves, covered by a piece of 1.2mm stainless, and underneath that we have 8 ceramic magnets. So the idea is that they catch most of it. If something misses that and ends up in there, the knock sensor will trigger, and we'll be waiting with a fire extinguisher or a fire unit to put out whatever it lights up, and hope like fuck it's not on a bad day.
You can see on here, I've got some warning conditions, multiple warning conditions for both speeds, drive shaft speeds, temperatures, and for the knock sensor. So I've managed to do that so it'll actually show up on the gauge as well. Multiple screens, not we can really see it very well. Knock, both the RPMs, or the speeds, and both the temperatures. The very first screen has got all four. I put it in as RPM and speed, and then the two temps. On the laptop, I can monitor everything. I've even put up a special heading just for Jesse. So as you can see, if the one speed drops below 1900 where the other one stays above, then there's a problem and the warning buzzer will go off. I have set a bit of a delay, so it'll actually drop below 1900 for a second before that buzzer goes off, and of course that can be adjusted. That's for the man who's configuring this, or commissioning. He's commissioning it. Same happens if there's a temp warning, and then if there's a knock, of course, going off as well. So all those things will trigger a warning in the system, which is what we wanted it to do. So it seems to be working just correctly, which kind of makes me pretty happy.
Now that lovely 10-metre loom, it will run from where the link's mounted in the engine bay, under the engine, until it gets about halfway down the chassis, where it will then drop down, follow the top of the rotor case along, past all these spinny things, and up into there somewhere, where it will go through the firewall into the cabin, where we then run the cabin loom.
So this one's been a little bit of a challenge, as I said, but I'm pretty sure we've managed to nail everything that he wants to put onto this combine harvester. And it shows that we can use link ECUs or ECUs for other purposes other than running just an engine. There's a whole lot of features that we can put into practice and works very, very well. We get support, and I'd like to say thanks to Simon from Link. He was a little bit dubious of me trying this at first, but I think he warmed up to the idea and saw that I was doing what I normally do, is solving problems. And Simon, what I actually did, I set it to a 12-cylinder, so it's a 12-cylinder distributed, 80-degree knock window. I think I've got every part of the knock system sorted in that sense. Just going to demonstrate the knock sensor as well. So I've got to bring this up to above 1900 RPM for the buzzer to stop. See, it's pretty simple. So what we're doing is we're measuring the 2 RPMs, or the 2 drive shaft speeds, and the temperatures. So you can also see I've got a warning system for knock control. If a bit of metal goes through this machine, being in Australia, metal on metal makes sparks. I think Jesse told me in the seed destructor unit that's being modified onto this combine, there is about 5 millimeters of clearance between the cutters. Bit of metal in there, makes sparks, fires out the back, things catch fire. Not the machine, what they're cutting, all the trash from that machine. I think they call it something else. Anyway, that stuff catches fire, so it gives them time to check out if something's going wrong out there. Get the fire extinguisher out. And Jesse's got to set that up. Good luck, Jesse. And Jesse is going to have to configure and set all this up, or commission it onto the vehicle. And any fault finding with that and that setup of that knock system, I'm not exactly sure how he's going to do it. Probably hit it with a hammer.
What do you reckon our stubble mats there to roll down the stubble so that it doesn't damage the tyres. As you can see on the tyres, all this damage here is all from the stubble chewing out the rubber. So hopefully those bad boys will stop that from happening.
So guys, I hope that's been helpful explaining sort of what we can do with this. I've run through a couple of setup videos for Jesse. I'll probably release them as well. And I'm just going to run through a couple of notes for Jesse right now. So thanks for watching. And if you want to watch the instructions for Jesse, go for it. Otherwise, we'll talk to you again soon. Catch you later. All right, Jesse. Let's go through this. And I'll show you what I've done and what you have to do to make it all work when it gets to your side. This little final stretch here, I haven't shrunk it yet, just in case you want to do something different. I've left a bit of shrink wrap on there. I think we should be pretty safe there. You can see that's RNF 100, pretty resilient. Of course, any places where it may chafe, put some extra protection around it. This is your tuning cable, included as we said. Right, I've got the pin out for you for this. And this little plug here, I've got it looped, that's the micro switch. So that's an earth to the micro switch. If we want to change it to a 5 volt or a 12 volt, they are in there. And the 2 speed sensors, if we want to put a 12 volt or a 5 volt to our speed sensors at any time, they're in this plug. That way they're not firing voltage down lines that aren't being used at present. It's just trying to keep it a bit safer and any issues there. Those are just our earth joins. Pretty simple, pretty basic in this area here. As I said, I've got a pin out for you. A couple of little bits of wire for 3-core wire if you do end up changing speed sensors. Right, down this branch, there's your firewall plug. Again, just hit a bit of shrink wrap there. Temp sensor, common Bosch NTC. These are a 12-1.5 thread. I think as long as there's a little bit of metal to metal contact on there, you'll set that up just fine. And the normal Bosch plug, nice and simple, the EV1 plug. Speed sensor wiring for speed 1 and speed 2. Tell me how many of these you want. I've got a few left, or if you want to get some new ones, I can do that. It's just going to take me a little bit to get them at the moment. But I've got 3 of them there. You've probably got some as well. Pull them out of your own trans. You see I'm just firing them in there. They plug in nicely. Micro switch. I've got it bridged because you said it's normally closed and it goes open circuit. Presently it's an earth and the signal back to the ECU. The booties can be pulled back. So the dark colour is going to be the earth and the lighter colour is going to be the return to the ECU. These plugs, the DTM3s, are both wired the same. So it doesn't matter which way they get plugged in, as far as if you need to change anything, they can, or testing, they can be swapped easily. So normally that loom, of course, is over there. Same deal, we've got temp sensor and a knock sensor. These are the same plug. So I'll mark it up on here that this is knock and this is a temp. There's our speed sensor. This stuff is 10 meters of it. So that gives you plenty. It's pretty hardy, the stuff, actually. But again, if there's any places that might chafe, put a bit of wrap around it. Firewall plug. I did make an OBD2 unit. This one communicates at 500 megabits. No, 500 kilobits. 500 kilobits. and the dash is at 1 meg, so that isn't presently working. It's for Android anyway. You've got one of those Apple things. I'll still send it over, because if we may find we can find an adapter, or one of the viewers might tell us about an adapter that works at a different communication speed. It runs bugger all amps, so just check the fusing, and if it's like a 20 amp, probably drop it down to about a 10, 7.5 to 10. Here we've got a CAN adapter plug for the gauge, so I actually just left the gauge wiring as it was. It's quite long, but I've put a couple of extras, put that extra one in there. Comes to the buzzer, mount that nicely. It should be waterproof inside the cabin, okay, so this isn't designed to be underwater, so hopefully the cabin is dry. This is just a generic switch for something if you choose to put it into the ECU on one of the digital inputs, okay, so I put it in now. Oh, I should say about that body plug. You can see here we've got 4 extra wires, so they go back to the ECU on AV volts and auxiliary outputs. If we want to put other lights or flashes or warnings in there, I did that, but it looks like we've probably got it sorted. Probably don't need to. So of course, because they're auxiliaries, they do go all the way back to the ECU. So if my suggestion of the penis mounted dog collar shock system for the driver wants to be enacted, you connect into one of those wires to trigger it. Of course, mount the gauge, it's pretty cool. Mount the ECU, throw some numbers in the laptop, set up the knock sensor. Right, Jesse, I think that's pretty all straightforward. I'm pretty confident you're going to get this sorted. You've kind of been involved in the whole process of making it and seen me late at night getting it all done. So I'm going to wrap it all up, put it in a box, get it ready to send over to you. Catch you later, mate. Come on, girls. Come on. Come on. Good girls. Come on. Come on. Chop, chop. Up you go. There you go. Enjoy. Good girls.
Alright mate, so this is the actual mill itself. So this piece here is the rotor. This is the bit that spins at 3000 revs. And this bit here is the stator, which sits still, and this is what the knock sensor will be attaching to. Hopefully to one of these M10 bolts here. So as you can see, there's not much clearance once that slips inside. It's pretty tight. Right, so now on the machine, and there's the engine sitting right up in there. You can sort of see it. Anyway, so this is the main power takeoff from the engine. So we come through this triple, don't worry, that we're getting a new belt for there. Triple rib C-section belt, 1-to-1, down to this jack shaft. This is the jack shaft where we're going to have temp 1 and speed 1 into this bearing housing here, and this is the little teeth we were talking about. From there we drive our straw chopper, which is this one here, which is all those hungry looking blades in there, and then off the inside one we're going to come down and drive the seed destructor, which is what we've been building. Right, now we're up in the engine bay. How's that for a radiator? So this is where engine management is, and the link will mount somewhere in this general area. And there we have our engine here, big 9 litre turbo inline 6, about 450 horsepower. And there's our power takeoff there, which is then dropping down to our jack shaft down the bottom down there. So the seed destructor itself, the frame attaches to the back of the chassis there. That's 100 by 100 by 10 RHS. Travels under the back axle, attaches to the chassis up there. None of this is done yet, we've got lots more gussets to put on here. Through to where our mill attaches to, and the drive for the mill. So our drive comes down through these bearings to this tyre coupler. This is where speed sensor 2 will be in here. So if that fails, the pulley will still be spinning, the shaft will still be spinning, but the gearbox and that shaft will stop. So this is all the bit I've made. So we've got our 90-degree drive gearbox. There's a big flange up under there. We've also got an auxiliary oil pump. This is for the oil cooler and also to feed that top bearing up in there. There's the tyre coupler again. And there's the mill mounted up on the frame. There's the flange and the taper lock that the rotor attaches to. And then here's the back of the header. So now we're in the back of the header. You've got the chopper there for chopping the straw into little pieces and spreading it back out in the paddock. You've got this big baffle plate here. Everything above the baffle plate is straw without any grain in it from that discharge beater up there. It comes down the baffle plate, and then of course this chopper swings down to join up with the baffle plate. Everything below the baffle plate is grain. There's the sieves. You got the rotor up the front, and the grain that separates the grain from the straw. The grain comes down, goes across the sieves, sieving out all the crap from the bit you want. Anyway, then all the weed seeds and all the small grain and crap ends up coming over the top and down into the destructor, where it then gets shot out the two vanes once I finish them. Right, now metal management. If anything breaks up the front and we have nuts or bolts or bits of chopped up wire or retractable fingers or what have you, they have to come down here and they're going to eventually end up in there. Now the idea is we've got the knock sensor there to let us know if it does make it to here, but the idea is to try and stop it from getting there. So I've made up this magnet tray that sits at the back of the sieves, covered by a piece of 1.2mm stainless, and underneath that we have 8 ceramic magnets. So the idea is that they catch most of it. If something misses that and ends up in there, the knock sensor will trigger and we'll be waiting with a fire extinguisher or a fire unit to put out whatever it lights up, and hope like fuck it's not on a bad day. Now that lovely 10-metre loom, it will run from where the link's mounted in the engine bay, under the engine, until it gets about halfway down the chassis, where it will then drop down, follow the top of the rotor case along, past all these spinny things, and up into there somewhere, where it will go through the firewall into the cabin, where we then run the cabin loop. What do you reckon our stubble mats there to roll down the stubble so that it doesn't damage the tyres? As you can see on the tyres, all this damage here is all from the stubble chewing out the rubber. So hopefully those bad boys will stop that from happening.